Okay, so when we left off last class, we were talking about how we were going to record in our databases, how we were going to record time. Right? The time was pretty simple, right? Right now it's a little after 2 p.m. So what time is it? It's a little after 2 p.m. Right? We would record that. So let's just take a look at some examples of things that come up. If you went to, in the United States, if you went to the NFL, the National Football League, this is not European football or soccer as we call it, this would be American football. If you went to the National Football League and you looked up a game, you would see, for example, if there was a game between the Denver Broncos and the San Francisco 49ers, and the game was scheduled to be on November 18th, 2018, the question is, what time does the game start? Denver is on Mountain Time, but San Francisco is on Pacific Time. However, NFL.com lists the game not when it starts on Mountain Time, which is 11 a.m., and not on Pacific Time, which is 10 a.m. They list it as though the game starts at 1 p.m., which is what time it is in Eastern U.S. time. Even though neither team is in that time zone and the game is not being played in that time zone, they list the game as starting at 1 p.m. Eastern time. So if you live in Denver and you want to look up on the website, when does the game start? The game starts at 1 p.m. Eastern time, and then you have to do the computation in your head. That means 11 o'clock my time. Or if you live in San Francisco, that means 10 a.m. 1 p.m. means 10 a.m. in San Francisco time. So how do we record in our database when the game starts? So one thing we could do is, should we record it, the start time in our database like this? Should we have a column that says the year is 2018, the month is 11, the day is 18, the hour is 1, the minutes is 0, and AM and PM is set to PM? Should we say that? Would this be a good way to record when the game starts? We could get rid of the AM and PM column if we take advantage of the fact that we could record hours in a 24-hour format. So we could have year, month, day, 13 is the hour, and 0 is the minute. This means 1 p.m. If a 1 was here, that would mean 1 a.m., right? So we could get rid of this column if we use the 24-hour format. So now if somebody in Denver wants to look up what time is the game, they bring up the website, we read this data out of our database, and we say the game starts at 1 p.m., but it's not 1 p.m. to them, it's 11 a.m. to them. So we would have to go into our database, read these columns, calculate what time that is, in the time zone that this was recorded in, and then convert it to the time zone that the person, the client who's looking on the website and wants to see what time the game starts, convert it to their time zone and then display it that way. That's a pretty intense computation. If we're going to do this a lot, this could get very intense. So do you think this is a good way to record time? Year, month, day, hour, minute. If we care about seconds, we could record seconds, but right now we're not going to cover that in this example. Do you guys think this would be a good way to record the time that an event starts? Any suggestions? Any ideas? No? You guys are sleeping today? Okay. Suppose, for example, there's lots of things we like to do with time. We want to tell somebody, maybe somebody has season tickets, we want to send them a reminder, hey, the game comes in 3 weeks, would you like to sell your ticket, or make sure you get ready to go, or something like that. So suppose today is October 25th, 2018. 2018, and we want to calculate how many days away is the game on November 18th. We have to do a computation. We don't care about hours and minutes. We care about the date, and the date of the event, and today's date. And we want to calculate that the number of days from this date to this date is 24 days, and tell the person, hey, the game's going to start in 24 days. So we want to read from our database when the game starts, and we want to look at today's clock and then do this computation. So we read these three fields out of the database, read these three fields off the current time's clock, and then we do this calculation. We have to do years minus years, because it could be years away. Multiply that by 365, because there's 365 days in a year. Then take the month, the 11th month, minus this month, the 10th month, month minus month, times 30, because there's exactly 30 days in every month. Right? Right, there's 30 days in every month. You guys are asleep, right? Some months don't have 30 days. Some years don't have 365 days. Some have 366 days. Right? So if we take month minus month times 30 and then add day minus day, we can calculate how many days there are. This is not going to work. Now we have to have a big chart. This month, January has 31 days, February has 28 days, but sometimes it has 29 days. So this is not going to work. This computation would get a little bit more complicated. And all we're trying to do is tell the customer, hey, this event is 24 days from now. So, so we have to come up with kind of a better strategy for doing time. So, and just another example of how things could, get somewhat complicated. Suppose you had a group of employees and you wanted to schedule a meeting. And they have a meeting, and let's say they're third shift employees. They work like kind of a midnight to 8 type of a shift. So suppose there's a meeting on November 18th, and it starts at 11 p.m., and it ends at 1 a.m. in the morning. So the meeting takes 2.5 hours. And not only does it start on one day, it ends on a different day. But it ends earlier in the day. 1:30 a.m. is early in the day, 11 p.m. is late in the day, but that's on a previous day. So we could record that the meeting is in 2018, on the 11th month, the 18th day, starting, and now I got rid of the AM PM column. So I'm saying the 23rd hour, 0 minutes, and it ends at 1 a.m., 1:30 a.m. Now, if we recorded the start and stop time, this is now we have events that have a start and a stop time. Not just a time, like when a football game starts. We now have a start and a stop time. We're making the assumption here, if we record this in our database, we're making the assumption that it starts and stops on the same day, because I recorded a date. So if I recorded it this way, it's a little bit confusing. It starts at 11 p.m. on November 18th, and it stops at 1 a.m., also on November 18th, which means the meeting stopped before it even started. And if you wanted to know if the meeting was live, if you wanted to look at the current time of day, and ask yourself, is the current time of day, is the start time before the current time, and the stop time is after the current time, meaning the meeting is currently live, maybe we just turn on a microphone or something like that. We want to pull these fields out of our database and then ask ourselves, when did it start and stop? Well, the way I recorded it here, since I only have a 1 day for both start and stop, I'm not handling the case where a meeting starts on one day and ends on a different day. I could just add more columns to our database table. I could have start year, start month, start day, start hour, start minute, stop year, stop month, stop day, stop hour, stop minute. How would you calculate the duration of the meeting? Suppose you wanted to tell somebody, hey, you have a meeting at 11 p.m. and it's 2.5 hours long. How would you tell them it's 2.5 hours long? We didn't record the duration of the meeting, we recorded the start and stop times. So what we do is we go into the database, we pull all of these fields out, and then we do that year minus year, month minus month, day minus day. If we do that whole computation, we'd have to have a big chart, how many days are in each month, to do a computation like this. Well, many times the start and stop of a meeting is on the same day. So you're doing all these computations for no reason. Okay, so how could we do a calculation like that and say that tell somebody that the meeting is 2.5 hours long? So is there any way you could think of that we can record time? Anything you could think of where we could record time? Now remember, time has to have a year, a month, a day. We have to know, like today at 2 o'clock, we have to know the day, the month, the year. There has to be some way to know the exact, we don't just say 2 o'clock. We have to say 2 o'clock on a particular day, on a particular month, on a particular year. We want to be able to record that, but we'd like to record it in such a way where we can do all types of mathematics, like how long is a meeting from start to stop, or how long ago did an event occur. So another thing we have to take into account, which we talked about earlier when we talked about the Broncos and the 49ers, they're in different time zones. We want to take into account time zones. So suppose you were in New Jersey, in the USA, like we are, and you wanted to record time in your database. So if you said 2018, November 18th at 2 p.m., 0 minutes, and you recorded that, what time is that in India? It's a different time. So this is 2 o'clock in New Jersey. This is not 2 o'clock in India. What we said was 2 o'clock. We know it's 2 o'clock somewhere. You guys know that song that's 5 o'clock somewhere? All right. So, okay. So what we also want to record is the year, the month, the day, the hour, the minute, and the time zone. So now if somebody in India wants to know how long ago did this meeting start, they could read these fields out of the database and know what time zone 2 o'clock is. Then they'd have to do a translation from 2 o'clock Eastern United States to Indian time, and then they could calculate what time it is there. So now we have to take into account the time zone. Okay. So the issues that we need to resolve, just a little recap, and the issues that we need to resolve is months have different amounts of days, years have different amounts of days, 365, sometimes 366. Hours from the future days may be lower than the current day. You could have a meeting that starts at 11 p.m., at the hour 23, the 23rd hour of the day, and the meeting ends at the first hour of a day, but it's a different day, it's in the future. So we have to do all these computations, and then there's also time zone differences. So how can we resolve this? Now, you guys, well, I'm sure you guys use Facebook or Instagram, and you go to your friend's Facebook page, and somebody just uploaded a video, and the video has attributes, obviously, in a database about the video, where the video is located, so they can display it, whose video it is, and it'll say the video was posted I don't know if you can see this, 1 hour ago, and it's from Instagram, so it's not even from Facebook. Someone posted on Instagram and linked it to their Facebook account. But the video was posted 1 hour ago. Now you're looking at this is your friend's video, you're looking at it, so they posted it, Facebook or Instagram recorded the time it was posted, and the time is approximately 1 hour ago. How could it have calculated that it's 1 hour ago? Suppose this person posted this, suppose they were in Greece and they posted it, and you're in the USA looking at it now. How would you know it was 1 hour ago? If the time was written in Greek time, that's a few hours ahead of us. It's just like there would be negative hours here, right? So we'd have to calculate where I am compared to where the time stamp when this was put on Instagram. So maybe they recorded the time zone, and then they know the time zone I'm in, and they can calculate my time and their time, and then tell me what the difference is. This is a computation. There's not an entry in the database that says 1 hour ago, and they keep updating the entry every hour to say 2 hours ago, 3 hours ago, 4 hours ago. They're recording the time the picture was posted. And when it displays on my screen, when I hit refresh to refresh the screen, the current time is taken and the time the picture was posted, the entry in the database, and a computation is done. And it's 1 hour ago. Come back an hour from now, it's going to say it was 2 hours ago. But there's no entry in the database that now has a 2 in it. The entry in the database is the time the picture of the movie was posted. So we have to figure out a better strategy than year, month, day, hours, minutes, time zones. It's too complicated. So I don't know who came up with this, but this is the legend has it that the Unix operating system became public on January 1st in 1970. January 1st, 1970. So they decided that that's when computer time began. Computer time began. January 1st, 1970. By recording time as the number of seconds since the Unix operating system started, January 1st, 1970, now we have to figure out which time zone. We have to pick a time zone to be the official time zone of the world. We say that on January 1st, 1970, at time 000000, we don't need to record the years or the month or the day or the hours or the minutes because we're just recording seconds. Just recording seconds. From the seconds, you can then calculate whatever you need to calculate. How many days ago it was, how many hours ago, how many seconds it was. But we're just going to record seconds. We can also record milliseconds, but it's very popular to record seconds. Most people don't care about milliseconds. You know, Facebook says the picture showed up 1 hour ago, then I'm saying it's 1 hour and so many milliseconds ago. So we're pretty much okay recording seconds. Okay, so now we just need to have an official time zone for the world. And Greenwich Mean Time is the one we're going to use. And then we'll record everything. You upload a picture onto Facebook, they're going to record how many seconds it has been from Greenwich Mean Time until the second the picture was posted, and then record that number of seconds. And if anyone in the world wants to know how long ago it was or when it was, they'll calculate what is the current Greenwich Mean Time in their time zone, and then do a second subtraction. If you want to know how many minutes, divide that number by 60. If you want to know how many hours, divide that number by 60, and so on. So what is Greenwich Mean Time? So, where is this official place where time begins? So Greenwich Mean Time, or GMT, is clock time at the Royal Observatory in Greenwich in London. It is the same all year round. They don't have any daylight savings time, so you don't have to worry about that. If your time zone uses daylight savings time, like in most of the United States, except for maybe Arizona, we use daylight savings time, but as you guys know, most of you know, in India they don't use daylight savings time. They just have one clock all the time. You don't have to set your clocks ahead and back twice a year like we do here. Okay, so, and when the sun is at the highest point in Greenwich, that's when it's 12 noon, high noon. Where that expression comes from. So Greenwich in London is considered the official place where the official clock of the world. So time starts, as far as computers are concerned, January 1st, 1970, in Greenwich, England, at midnight. That's when computer time started. And if you want to record any time, you just record how many seconds it's been since then. So here's a map of the world's time zones, and here's time zone 0. and it goes right through Greenwich, England, right through London, right there. So then, depending on where you are, you could be +1, +2, +3, +4 hours away, or -1, -2, -3, -4. So on the East Coast, where we are, we're -5, but right now we have daylight savings time, so we're really -4. So we'll go between -4 and -5, depending on if we are within daylight savings time. So if you wanted to, so if you're, now Facebook is located in California, their servers are out on Pacific time, but they're also located, they also have servers in Ireland, which looks like that covers Greenwich Mean Time. It looks like Ireland is on Greenwich Mean Time. And so Facebook servers are on both of these, so you could upload a picture. You might get uploaded on a server in California, you might upload it on a server in Ireland. And they're going to record it one time. Doesn't matter where it goes, they're going to record it based on Greenwich Mean Time. Then wherever you are in the world, if you're in India and you're looking at the picture, where's India? Or here. So if you're looking at the picture, then they'll calculate the time stamp in Greenwich Mean Time plus this many hours away. 60 seconds times 60 minutes times 5 hours. Add that to the time, and they'll know exactly what time it was in India when that picture was posted. Okay. So this is going to require us, if you want to do hours, minutes, days, how many days ago was something, or how many hours ago, you have to do these translations. So a minute has 60 seconds, an hour has 60 times 60, which is 3,600 seconds. A day has 24 hours. So if you take this number and multiply by 24, you get this many seconds, or in a day. A year has 365, usually, days in a year. If you multiply that by 365, you'll get this many seconds in a year. So, when you create your database entry and you want to record time, if you're recording time in seconds, it's common when using a MySQL database, or most databases, if you make a data type of type integer, you will by default get a 32-bit number. With a 32-bit number, with a 32-bit sign number, meaning it could have a positive value or a negative value, that means one of the bits, you remember this from your computer architecture class, one bit tells you if it's a positive number or a negative number, and then you have a remaining 31 more bits. So a 32-bit number is 4 gig, but because one bit is for the sign, you only have a 2 gig, little over 2 billion seconds that you can go into the future. The minus sign means seconds in the past. So if you want to record something, something happened before 1970, or somebody was born before 1970, you want to record their birthday, you would record it as a negative number. It's how many seconds prior to January 1st, 1970, in Greenwich Mean Time. So we can record approximately 68 years before and 68 years after 1970. So if you're using a database to record time, and you're recording in seconds, not milliseconds, seconds in Greenwich Mean Time, how many seconds has it been since January 1st, 1970 at 12 a.m. Greenwich Mean Time until the time you're trying to record? You could go 68 years in either direction, which means if you're using a 32-bit integer, you could go into about the year 2038. There's going to be, remember they had the Y2K fear, they were worried, well, everybody's calendars would not work because they recorded the year in a 2-digit number, so it would go like 97, 98, 99, 100 would become 0, and then it wouldn't be the year 2000, it would be the year 1900 instead of the year 2000. It's a big fear all these computers were not set up to handle that time. Well, in 2038, there's going to be a problem. So anybody who used a 32-bit number, which is the common number that everybody just, they create a field, a start and a stop field in their database for seconds, and they just make it an integer. Oh, I got plenty of time. You got plenty of time until after 2038, you're not going to be able to record time. So there's going to come a point where you add one more second and it becomes some big negative number from the year 1902. So if you happen to have databases, you're writing some application, and you're going to record time, and your business that you're creating is going to be around past 2038, make it a double. Make it 64 bits, don't use 32 bits. You won't have this headache. No, well, it won't be too much of a headache. You just have to go and recreate all your database tables, making the time be 64-bit numbers, and then copy all the data over to the new tables and delete the old tables. But just do yourself a favor, if you're going to record seconds, use 64 bits, don't use 32 bits, and then it'll be good for centuries to come. Okay. All right. So if we were going to write code that tells somebody in Denver that the game starts at 11 a.m., not 1 p.m., I'm surprised the NFL website doesn't do this. It's not that hard to do. Here's an example of PHP code, but same thing could be done in Python, same idea. We would want to go into our database, and we would go into our database. We have a database connection. We will call the function that logs us into our database. So you want to have a standard function that always logs you into your database. You have your SQL statement. So in PHP language, a $ in front of a string means it's a variable. So we say select the event name and the start field. And the start field is going to be the number of seconds since January 1st, 1970, Greenwich Mean Time, 12 a.m. That's recorded in hopefully a 64-bit number, but it could be a 32-bit number. We get it from our table. This is attendance, events, groups, start and stop. So now what we can do is we can record the start and stop dates, and in seconds we don't care about years, months, and all that stuff. We can take the two numbers, do a subtraction, and calculate how many days ago it was, how many minutes ago it was, how many hours ago it was, and the math is very easy. And then we say for a particular event where the event ID equals some variable event ID and the group ID equals some group. So it's some group and an event, and we get the name of the event and the number of seconds when the start time is. And we bring those results back to our event result, and we log out of our database. And then what we do is we go read the results out of our database. So what we do is we say, we read the results, we read a row, we fetch the first row, we read the event name, we read the start, we read the stop. Well, we're not actually using the stop. And now we'd like to print out the start. We'd like to tell the person when the event starts in their own time zone. So if they are in Eastern time zone, and this PHP has a whole big list of every time zone, and this is actually saying Eastern time zone, which is 5 hours away from Greenwich Mean Time, and it takes into account daylight savings time, Eastern daylight savings time. So it'll handle both cases. You don't have to update this when you go into daylight savings time. So once you run this statement, you are telling the server, I would like all time to be reported as though it's Eastern USA time. Don't give me Greenwich Mean Time. Don't tell me the game starts at 4 p.m. in the afternoon when it's starting at noon. That's what we're basically saying. Then you can call PHP functions where you say, give me the month, day, and year, capital Y means the 4-digit year as opposed to little y, which will give you the 2-digit year. You can look up in the PHP manual. But what I'm basically saying is, take the start seconds, how many seconds it has been since January 1st, 12 a.m., 1970, Greenwich Mean Time, and tell me what that is in month, day, and 4-digit year in East Coast USA time, and record that as my start day. Now I want to know what hour is it. Is it 11 a.m.? Is it 1 p.m.? Now tell me what hour it is. So take the start seconds. I'm doing a second computation. I could have done this all in one big step. I'm just kind of spelling out how I can do hours, minutes, and seconds. I could repeat this. So this is the same number of seconds. This operation didn't change the number of seconds, so it's the same number of seconds. Let's say, tell me what hour it is. That's 11 a.m. or 1 p.m., whatever it is, in Eastern time. And then tell me what minute it is. And then tell me, is it a.m. or p.m.? And I'll record that. Now I can just take these 4 variables and print them out. I should have done that. I should have wrote print and then printed out these 4 variables. And then that would tell the person. The game starts on November 18th at 1 p.m. Eastern Standard Time. But if you were in Mountain Time, then I would want to put in Mountain Time here, and then I would display it in Mountain Time. Okay. So time is not simple. You might not appreciate what's involved when Facebook is doing this. When Facebook is saying this is 1 hour ago, and then an hour later you hit refresh, it says 2 hours ago, and then it'll go 3 hours ago, and then 4 or 5, I don't know how many go, and then it goes 1 day ago and 2 days ago, and they start making it more vague. They're not going to tell you it was 2 days and 4 hours ago. They'll just say it was 2 days ago, or 3 days ago, and then eventually over a week ago, and after a while they don't have to worry about too much computing to do. But this is how they do it so they can have times throughout the world. So, all right, so does anybody have